I'm going to give more or less a cook's tour of some patterns that we're using in Syngenta. I think it resonates actually with a lot of stuff, particularly what Brian mentioned this morning, actually. I can see some very similar constraints that we have on our deployment of things to what Brian was describing. So first of all, our ambition is, Syngenta is a seeds and crop protection company, essentially. Our ambition is to help all farmers around the world meet the challenges of food security. As a consequence, we're a very large organisation, very global organisation. We do R&D in many countries around the world. We have about 5,000 people that we employ doing that, and our three kind of major sites are in the US and in Europe. But with that as a network of research areas. But overall, and globally, we employ about 29,000 people, so quite a large organisation, but definitely research-based. It's driven by our research activities. But, the changes that are actually happening and what we're expecting to happen are that we become very much, the industry becomes very much service-driven. It's about delivering really good value services to farmers. And a lot of what we've been talking about today, I know, has been upping the game for researchers to really help researchers get into it. But at the end of the day, we also have to think about how we deliver value to a farmer that improves yield, socio-economic outcomes of interest. I put these three up here just to kind of describe that, but let me just describe that top left-hand one because I don't want to eat into too much time. That top one there, mechanized rice planting, for example, the idea that a farmer can phone or communicate with a distributor and say, I'd like this planted out in 3 weeks' time or 4 weeks' time. To deliver a service that does that, there's a lot of domains of data you have to bring together to make that happen. You obviously, there's a great deal to do with agricultural engineering there. If you're going to build machines that can plant rice, you have to understand the morphology and growth development of rice plants over a very specific 48-hour period so that you can deliver viable plants. You need to understand the material science around the material substrate that you're going to grow those plants in. This is a great deal of disciplines that beyond biology and chemistry, which have to be brought together to do that. And so these new services that we expect the industry to be delivering for farmers are calling on huge capabilities in terms of bringing data, diverse data sets together. And then the questions that we're asking of the data are becoming much, much more sophisticated, and these competency questions are just examples. But as you can imagine, as you're building up these really cool services that really help farmers, we need to be able to penetrate that data with some really complex questions that go beyond single databases. And so ontologies are just they're one of the tools that we have to be able to, the battering rams really, to be able to bring data together. But just to return to Syngenta, so we, like many organisations, work with blinkers on a day-to-day basis. We rely on business processes. Research works by, in crop protection, for example, synthetic chemists doing one thing, passing it on to biologists who test another thing. That might eventually get onto field trialling, and there might be a bit of circling back on that. But as a result, we end up with many, many silos of data, but to meet that demand we've just been describing, we need to be able to bring those together, and the cost of doing that is very expensive. We've done. I've been with Syngenta since 1987. It seems we've done loads and loads of these surveys of working out what's the best way to do data integration. But essentially, there's a great deal of time that's spent in getting data in the good condition so that you can bring it together and actually exploit it at the top right there and do your cool in silico science. And the thing is, those pink steps in there that have to be done, they're all done by data scientists. And these are people who should really be doing the cool data science, not the lifting and shifting and moving around of data. And there are many reasons why this is the case, and it's the state of the art, but it is something that has to change, and it's something that we have been looking at inside Syngenta, and I know other companies do as well. And just to kind of give you a feel for that, so if you've got, I think if you have this end game in mind where we're delivering better services that are meaningful to a grower, and you have these data there, then and you've got to bring together vast amounts of data. There are these, there's a role here for things beyond the data science, business models, leading by example, showing people how to share data. This is all part of a community of practice and a network of people that need to work together to push this forward, rather than waiting for a single organisation to make a change. And we've certainly been involved with a number of organisations and try and make ourselves a participating part of that community, so that we can not just push it forward for the benefit of the community, but there is a business benefit for us doing that as well. There's no business benefit in holding the single definition of what a vascular leaf is, for example. It's far better if everybody shares that. So I'm going to look at four. I'll just give you a description of four patterns or things that have are starting to make a difference in Syngenta. I don't by any means want to leave you with the idea that we are the most forward-thinking and progressive organisation. We are certainly trying and moving forwards, and I think we probably share some of the frustrations that other people do. But I just want to talk about these four things: a data architecture framework to support that exploitation of data, and how we've kind of evolved our reference terminology over to ontologies, so we're very much starting in that area. An example of benchmark scenario planning, which I'll skim over because a colleague of mine on Thursday is giving a detailed description of the mappings that we're using in that, and then extracting some structured data from documents. So first off, until 4 weeks ago, I was head of data architecture. I've got a new job now. But part of that is to work out how we can start to treat data as an asset. Rather, in the UK, we have these adverts called "A dog is for life, not for Christmas." You don't give away dogs and they last for Christmas. If you take a pet, you take it for life. And we want to have that kind of attitude with our data. When you produce some data, we want that to be an enduring asset that the company can reuse and exploit and get more and more value from. And in order to do that, we need to change the way that people think about how we share and manage our data. So I was kind of given that job a few years ago, and I found it really, really hard to even engage with IT groups to find out what it is they're doing with data. So I kind of created this framework of just 5 buckets that I wanted people to use in the context when we're having a conversation about it. And I started with data integration. And as soon as I started talking about data integration, people wanted to talk about other stuff, quality and access and trust and security. So what I did was I had this framework, but the bit on the left-hand side there is the bit that's absolutely fundamental. If we get that right, everything else falls into place. And it's describe, share, reuse. It's just saying to people, when you have your data and you produce your data, describe it well so someone else, when they pick it up, knows what it is and what it means. And the share is obviously to encourage people to start to get back into sharing, and then reuse as a mentality that they should be doing. So that's worked quite well now, and it allows now our data architecture teams to help, shall I say, help encourage those designs that now go into part of our ecosystem to have data that's much more reusable. Historically, we have used reference data, reference terms for unifying the codes that are used in our systems, and that has worked really well. It's just so pedestrian. It sounds that we've done that, but actually over a decade and a half, it's made data highly integratable. The only thing is that now we want to get to this bottom left-hand thing I've mentioned there, the concept of maize as a biological species, or maize as a commodity, or maize as a crop. We want to now get into the meanings and understanding the semantics of these things, and that goes beyond what you can do with a set of reference terms. So we need to move now, and we're just starting to move from this system of highly prescribed lists to a system where we have a Syngenta knowledge graph, and those values are sent back in the domain ontologies. And but with that comes the ever-burdening question of what's the governance around that. We do love governance in Syngenta. So as a result of that, when you look at that, you find we have all these extra roles now: ontology librarian, ontologist, and design reviewer. These are things that don't exist in a normal IT organisation. So this is a kind of a leap that we have to make and understand how it's going to work. So moving from standard reference terms. Benchmark scenario planning is really a view for us to. This is a collaboration we're doing with AGCO and University of Southampton and University of Aberystwyth, and it's really to take that idea, that ancient idea of benchmarking, how am I doing against my neighbour, but see if we can industrialise that somewhat by taking some detailed measurements of factors around portions of a field and clustering those to build up scenarios that match a neighbour's questions. And as I say, on Thursday, my colleague Sami Kanza, who's been working on that project from the University of Southampton, will be giving a talk on that. And then my fourth example here is kind of like, it's stating the obvious thing, but it's really quite untouched, is that the regulatory framework in which businesses like ours work rely on the document as the unit of currency. So every time you want to submit something for a regulator for approval, what you're actually submitting is huge piles of study documents, and these are prescribed by the regulator. You know, it's not like you have a choice. You can't dump them the data necessarily. They're after specific documents and specific studies. And of course, that's a huge, huge amount of knowledge and useful information. And so a combination of our ontologies and vocabularies can be used now as a part of the knowledge graph with concept and entity extraction, so that we can start to build up a bigger and bigger set of structured data, which is much more easily queryable. And this also helps us particularly with left-hand shift. So a lot of this work is done at the right-hand end when you're getting to development and submission. But this is data that could help us remove false positives from research pipelines, for example. So being able to feed this back in a structured way and integrate it with other data is very helpful from a business point of view. But it also, I think it's really a kind of an illustration of where I think regulators should be. I mean, I think they should be thinking beyond the study report. We're still creating study reports. But it should be a lot more focused, I think, on data packages and perhaps structured data. And part of this community that we're operating in should also include the regulators as well. Thank you. I mentioned that we're operating in that that community. We are a GODAN partner as well, and we sponsored this work on global data ecosystems for agriculture. But I mean, it was really, this formed a great deal of our kind of thinking, and I've used this as evidence inside Syngenta to try and just progress the thinking around data architecture. It's about getting data prepared and ready so that it is an asset that can be reused within the company. It's very difficult in a traditional IT organization to do these things. That just isn't the way they work. Okay, and I will leave it there. Thank you.